Good morning, everyone. Hope you are all staying safe and hopefully indoors. In the previous lecture, we talked about Chapter 6 and the theory of the firm or the theory of the producer. There we talked about the production function, total product, marginal product, and average product. In today's lecture, we are going to talk about a concept which is very much related to the theory of the firm or the theory of the producer, which is the analysis of costs. So whenever there is production, costs of course exist because firms must pay for their inputs or for their factors of production. They have to pay wages for the labor they are hiring. They have to pay interest payments for the capital they are borrowing from banks. They have to pay rent for the land they are renting, and so on and so forth. So whenever there is production, costs of course exist. There are also costs for the raw materials that the firm imports. So costs affect the input choices. Which inputs should the firm use? Which inputs or factors of production should the firm rely more on? Should it use more labor, more capital? Because it differs from one country to another. For example, some countries, labor are very expensive. That's why in these countries like Germany, for example, firms rely more on capital intensive techniques, which are techniques for production that use more capital than labor, because labor there is very expensive. In countries like Egypt, for example, and China, labor is much cheaper. That's why in these countries, those firms or those producers use more labor-intensive techniques, which are techniques to the production that rely more on labor than capital. So costs affect which inputs the firm chooses, which investment decisions to take, okay, and even the decision of whether to stay in business or not, as we will see later on. Businesses want to choose those methods of production that are most efficient, those methods of production that produce the maximum attainable output at the lowest cost. And this is something that we are also going to study, because every firm will face many methods to production, okay? And it has to choose the one that is the most efficient, the one that produces the maximum level of output at the lowest possible cost, as we will study later in the appendix. So in this chapter, in chapter 7, we are going to study, as we did with the production process, we're going to study the total cost curve, the marginal cost curve, and the average cost curve facing the firm. So we are going to start with the firm's total cost. Let's consider a firm that produces a quantity of output, which we're going to call Q, okay, as is clear from the first column in this table. And this firm uses the following factors of production or inputs to produce that output Q. It uses land, labor, and raw materials, okay? So the firm's accountants want to calculate the total cost incurred by the firm to produce that output, okay? So if we look at this table, we'll find that the first column has the quantity produced, okay, by this firm, the quantity of final goods produced by this firm, Q, which starts from 0 when the firm produces nothing, and then the first unit, second unit, until the 6th unit, okay? And the last column in this table gives us the total cost, okay? And as you can see, as quantity increases, as the quantity produced by the firm increases, as Q increases, the total cost facing the firm will increase, okay? And we will find out that this total cost that the firm will be facing will be divided into two components, as is clear from the second column and the third column. So this total cost will be divided into a fixed cost and a variable cost. And this is what we will be explaining in the next slides. We will start with the first component of the total cost, which is the fixed costs. What are fixed costs? From its name, these are costs that are fixed, okay? These are costs that must be paid even if the firm produces zero output. That's why if you go back to the previous table, you will find that the fixed cost has a number, has a figure, which is $55, for example, okay? Corresponding to zero level of output. So even if Q is zero, okay, we will find that the fixed cost has a number. So fixed costs are expenses that must be paid even if the firm produces zero output. Another name for fixed costs is sunk costs, is overhead, okay? So all these are synonyms. What is an example of a fixed cost? If you remember the example that we discussed when we talked about the theory of the firm, okay, suppose that after you graduate, you decided to open up an economic consulting office, okay? So the first thing you're going to do in this business is to rent an office space. So let's say that you went to a certain building, business building, and you decided to rent a specific office space in this building. Okay, so you will start paying a rent for this office space that you have rented. Okay, you will also go to a bank and take a loan in order to start furnishing this office. Okay, buying desks, chairs, and so on. Okay, so you will start paying an interest rate, okay, for the loan you have taken from this bank. So all these are costs that are fixed, that have to be paid in a specific amount, okay? The monthly rent that you have to pay for the office space, the interest rate that you have to pay monthly to the bank, okay? All these costs are fixed regardless of whether you started producing or not. That's why even if Q is zero, we will find that the fixed cost has a positive number, okay? So because fixed cost is the amount that must be paid regardless of the level of output, whatever the level of output is, you have to pay this fixed cost. You have to pay the interest rate to the bank. You have to pay the monthly rent to the building owner, okay? So it remains constant. This fixed cost remains constant no matter what the level of Q is. That's why if we go back to the previous table, you will find that the column for the fixed cost is positive and starts from 0Q, okay? So when Q is 0, we still find fixed cost to be a positive number, which is in our example, $55, and it remains fixed, okay, whatever the level of Q. Because as we agreed, this fixed cost is an amount that has to be paid regardless of the level of output. That's why it's fixed, okay, whatever the level of Q is. Second component in the total cost facing any firm is the variable costs. Okay, so again, from its name, these are costs that vary as output changes. Okay, examples include the raw materials purchased to produce output. So of course, we are going to import more raw materials if we need to produce more output. So raw materials in this case will vary with the level of output produced. Okay, the number of workers hired will also vary with the level of output produced. Okay, at the beginning, when my level of production is small, for example, I could just do with 2 workers. But the more output that I will need to produce later on, okay, will require more workers to be hired. So as you can see, workers in this case represent an example of a variable cost because they vary with the level of output. The electric power required to operate my factory, okay? Of course, the more I produce, okay, and the bigger the larger the number of shifts required to produce more output, this will require more electric power. Okay, so electric power here is another example of a variable cost. Okay, so that's why variable costs will begin at 0 when Q is 0. So before I start producing, I will not be needing any raw materials, I will not be needing any workers. Okay, that's why variable cost will be 0 when Q is 0. But as Q increases, we will find that variable cost will increase as well. That's why variable cost is the part of the total cost that will be growing with output, because we agreed that total cost equal fixed cost plus variable cost. Okay, and we know that fixed cost is a fixed number, okay, whatever the level of Q. But variable cost will increase with the level of Q. That's why variable cost will be the part of the total cost that will grow with output. So the changes in the total cost column, okay, will represent the changes in the or will represent the variable cost. So the jump in the total cost between any two levels of output, okay, between any two levels of Q is the same as the jump in the variable cost. Let's use this table again in order to better understand the two different types of cost that I explained in the previous two slides. So on this table we have the quantity Q, which is the level of output produced, okay, by this firm. It starts from 0 until 6. We have in the second column the fixed cost. We have on the third column the variable cost, and in the fourth column we have the total cost. So as you can see, the fixed cost is a fixed number, okay, that remains fixed, okay, from its name. It's a cost that is fixed no matter the level of output produced by the firm. And it starts even at a level of 0 output produced. Why? Because as we said, this is a cost that has to be produced even if I haven't started production yet, because I already took a loan from the bank and I need to pay interest payments on this loan. I already started renting an office space from the building owner and I have to start paying the monthly rent to this owner, even if Q is still 0. That's why the fixed cost will start with a positive number at a level of output 0, and this positive number will remain fixed, okay, for any level of output produced later on. So even if I'm now producing 6 units of output, I will still be paying the same $55. Why? Because the interest payments I'm going to pay will not change. The monthly rent I'm paying to the landlord or to the owner of the building will not change, okay? So that's why the fixed cost will be a fixed number, okay, starting from 0 level of output. What about the variable cost? The variable cost, as we said, it is a cost that varies with the level of output. That's why it will be 0 if I haven't started production yet. Once I start production, I will need to start hiring labor. I will need to start importing raw materials. So the variable cost will have a positive number only from a positive amount of Q. Okay, so at 0 level of Q, variable cost will be 0, but starting from 1 onwards, variable cost will have a positive amount and it will increase with the level of output produced. Okay, because in this case, I will need to hire more labor, I will need to import more raw materials, and so on and so forth. What about the total cost? The total cost is the summation of column 2 and column 3. So the total cost facing any firm is equal to the fixed cost that this firm has to pay, okay, no matter what the level of production is, plus the variable cost at this level of output. So as you can see, the total cost is also increasing with the level of output. However, it still has a positive amount when Q is 0, because this is equal to the fixed cost. So when Q equals 0, the total cost is equal to 55 fixed cost plus 0 variable cost, which is 55. At a level of output produced 1, the total cost will be 55 plus 30, which is 85. Okay, at a level of output 2, the total cost will be 55 plus 55, which is 110. Okay, so here the changes in the total cost, okay, will be equal to the changes in the variable cost. Why? Because total cost is equal to fixed cost plus variable cost, and fixed cost is fixed. That's why any changes in the total cost will be equal to a change in the variable cost. So let's see this. A change from a level of output equal 0 to a level of output equal 1, okay, this will result in a change in the total cost by 85 minus 55, which is 30. And this 30 is exactly the change in the variable cost from 0 to 1. Okay? If we look at a change in output from 1 to 2, here the change in the total cost will be 110 minus 85, which is 25. Okay? And this is exactly the change in the variable cost from 1 unit produced to 2 units produced, which is 55 minus 30 equal 25. Okay? So any jump in the total cost will be exactly equal a jump in the variable cost, because the fixed cost is fixed by definition. Here again summarize all the definitions that we have taken so far. Total cost, it represents the lowest total expense needed to produce each level of output Q. So by definition, the total cost facing any firm, it is the lowest total expense needed to produce each level of output Q. This total cost starts from a positive value as we agreed, and you can check again from the previous table. It starts from a positive value, and this positive value is the value of the fixed cost. So it starts from a positive value when Q is 0, and it rises as Q rises. Okay, but at which rate? What is the rate at which total cost rises? Okay, this is what we are going to study when we study the marginal cost, because the marginal cost, okay, is the rate of change in the total cost curve, which we will study later. Okay, what about fixed costs? Fixed costs represent the expenses that are paid out even if there is no output produced yet by the firm. So it is unaffected by any variation in the quantity of output. It remains fixed whatever the level of Q is. What about variable cost? It represents expenses that vary with the level of output, such as raw materials, wages for labor, the price of the fuel, okay, the cost of fuel used. So by definition, total cost is equal to fixed cost plus variable cost. So let's look at this graph. It summarizes all the concepts that we have studied so far. So here on this graph, on the y-axis, we have the cost, okay? Total cost, variable cost, fixed cost, any cost in dollars. On the x-axis, we have Q, which is the level of output produced. It starts from 0 and increases. Okay, what about our cost curves? So let's start with the fixed cost, okay? As we agreed previously, fixed cost is a cost that is fixed no matter the level of output, okay? And in our example, it was 55. That's why we are going to put it on this graph as a horizontal line, okay, at 55. So we will start at 55 on the y-axis, okay, and we're going to draw a horizontal line, which means that this fixed cost is 55 when 0 output is produced. When 1 unit of output is produced, it remains fixed at 55. When 10 units of output are produced, it remains fixed at 55. So this is what we mean by a horizontal line at 55. Okay? What about total cost? As you can see on this graph, total cost starts from the fixed cost. It starts from 55, okay, on the y-axis. So it does not start from 0, because as we said, the total cost is equal to a fixed cost plus a variable cost. So even if Q is 0, we'll find that the total cost is 55. That's why the total cost curve, okay, starts from the fixed cost, which is 55. And then it increases. So it is an increasing curve. But as you can see, at the beginning, until I think maybe 3 units of output, or when Q is 3, okay, you can see that the curve is increasing by a decreasing rate. So it looks as if it is a concave curve until Q is equal to 3, okay? After that, we find that it is still an increasing curve, but the rate is changing. The slope is changing, okay? So now it converted to becoming an increasing curve, but at an increasing rate or at an increasing slope. So it's becoming convex, okay, from 3 units of Q onwards. So again, as you can see, the total cost curve, it is an increasing curve that starts from the fixed cost. It starts from a positive amount on the y-axis, which is the amount of the fixed cost. And then it is an increasing curve. However, it increases by a decreasing rate at the beginning. So it is concave at the beginning, and then it shifts to becoming a convex increasing curve afterwards. Okay, why is that? This is something we're going to explain when we talk about the marginal cost, because the slope of the total cost, as you all know, is the marginal cost. Okay, so we were able to draw on this graph the fixed cost, which is a horizontal line, okay, at the point of 55, and we were able to draw the total cost. What about the variable cost? Where is the variable cost? From the definition or from our equation, the variable cost will be the difference between the total cost and the fixed cost. So it's this gap, okay, as you can see this line, okay, which is the gap between the total cost and the fixed cost. So the variable cost will be equal to total cost minus fixed cost, okay, represented on this graph as the gap between the total cost and the fixed cost curve, okay? So after looking in the previous slide at the graph of the total cost, the fixed cost and the variable cost, and we saw how the total cost curve changes from being an increasing curve that is increasing at a decreasing rate to an increasing curve that is increasing at an increasing rate. So there we talked about the curvature of the total cost curve. The curvature, which means that it was at the beginning, it was a concave curve, and then it was converted to becoming a convex curve. So this is what we mean by the curvature of the curve. So talking about this curvature, or the rate at which the total cost curve was increasing, or the slope of the total cost curve, all these are the same as talking about marginal cost. So it's normal to talk now about the marginal cost curve, or the marginal cost, or the slope of the total cost curve. So, like any marginal, the marginal is the change in the curve when we produce one more unit. So it is the change in the total cost when one more unit of the good is produced. Or in other words, marginal cost denotes the extra costs incurred in producing each extra unit of output. Okay, so when we produce one more unit of output, how does the total cost change? This is what we mean by the marginal cost. So we could measure the marginal cost from either the total cost column, which is the changes in the total cost, okay, associated with producing one more unit of output, or we can also measure the marginal cost from the changes in the variable cost column. Okay, so changes in either of these, either the total cost or the variable cost, will give me the marginal cost. Why is that? Because we agreed previously that the total cost is equal to the fixed cost plus the variable cost. And having fixed cost being fixed, this means that the change in the fixed cost will be equal to 0, because fixed cost is fixed by nature, so it's not changing. That's why changes in the total cost, which is what we mean by the marginal cost, could also be derived by the changes in the variable cost, since changes in fixed cost are 0 by definition. Now let's look at these two graphs, okay, which will help you better understand the things that I was explaining in the previous slide regarding the total cost and the marginal cost. So as you can see the graph on the left-hand side, this is a graph for the total cost curve. Okay, so we have on the x-axis Q or output level. Okay, we have on the y-axis the total cost in terms of dollars. Okay, so as you can see, the total cost curve, it is an increasing curve. It starts from a positive amount, even if output was zero. Okay, so it has an intercept, this positive amount. When output is zero, this is called an intercept. So even if output is zero, it still has a positive value. Okay, and this positive value, we agreed that it will be at 55, which is the value of the fixed cost. Okay, so the total cost curve starts from a positive value, okay, and then it increases, but it doesn't increase by the same rate. Okay, at the beginning, until a certain range of output, the total cost curve will be increasing by a decreasing rate. Okay, as you can see, okay, from this figure, the slope of this curve is decreasing. It's getting flatter, okay, until we reach an output level of 3. After 3, we find that the total cost curve will be increasing, but by an increasing rate. Okay, so it is the slope is getting steeper. This slope of the total cost curve is what we call the marginal cost. That's why moving from this graph on the left-hand side to the one on the right-hand side, okay, which gives me the marginal cost curve, you can see that the marginal cost curve will be downward sloping until 3 units of output being produced. Okay, this is reflecting the decreasing slope of the total cost curve in this range. And after 3 units of output are being produced, okay, the marginal cost will be an increasing slope. Okay, so the marginal cost curve will be first a decreasing curve, okay, and then it will be an increasing curve. Okay, the decreasing curve will be reflecting the concavity of the total cost curve in that range of output. And the increasing curve of the marginal cost will be reflecting the convexity of the total cost curve in this range of output. Okay? Now we will move to the average cost. So the average cost, as you all know, it is the total cost divided by the total number of units produced. Okay? And just as we separated or divided the total cost into fixed and variable costs, we can also break the average cost into fixed average cost and variable average cost, as we will see in the next slide. This table collects all the concepts that we have studied so far in the analysis of costs in one table. So we start with column 1, which gives us the quantity produced, okay, starting from 0 and ending by 6, for example. Then we have the fixed cost column, okay, which, as we agreed, it will be a fixed number starting even from 0. Okay, when Q is 0, we still have this fixed number existing, okay, and it will remain fixed no matter what the level of Q is. So it starts at 55 and remains 55 till the end. Variable cost, the third column, is for variable cost, and as we said before, variable cost is 0 when Q is 0, and then it starts increasing as Q increases. Okay, there are some missing parts in this table, and it is for you to practice filling these missing parts, okay, to make sure that you understand all the concepts well. Then for the fourth column, we have the total cost, which is the summation of the fixed cost and the variable cost. Okay, column number 5 gives us the marginal cost, which is, as we said, it's either changes in the total cost column or changes in the variable cost column. When we increase output by 1 unit. So every time we increase output by 1 unit, we see the implication of this on the marginal cost. Then we have in column number 6, the average cost, which is by definition equal total cost divided by Q. So when Q is 0, average cost will be total cost, which is 55, divided by 0, which is infinity. Okay, when you divide anything by 0, you get infinity. Column number 7 is average fixed cost, because we agreed that since total cost is divided into fixed cost and variable cost, we can also divide or break down the average cost into average fixed cost and average variable cost. Okay, so average fixed cost will be fixed cost divided by Q, which is, again, if we're talking about the first row, which is Q equals 0, it will be divided by 0, okay, which is, it will be fixed cost 55 divided by 0, which will remain infinity, because dividing anything by 0 will give us infinity. Okay, then you can calculate it for the remaining levels of output. Column number 8, which is the last column, it gives us average variable cost, which is variable cost divided by Q. Okay, for the first row, it will be 0 divided by anything is undefined. Okay, and then we can do it for Q equal 1, Q equal 2, and so on. As we agreed, the average cost can be broken down into an average fixed cost and an average variable cost. So let's look at each of these types of costs in detail. We'll start with the average fixed cost. The average fixed cost is by definition equal to total fixed cost divided by Q, okay? But since fixed cost is a constant figure, okay, it's always 55 according to our example. So dividing this fixed number by an increasing level of Q, okay, gives a steadily falling average fixed cost curve. That's why we'll see in the next slide that the average fixed cost curve is a decreasing curve, okay? And it keeps decreasing. Why? Because you are dividing a fixed number in the numerator by an ever increasing number in the denominator, which is the Q. Okay, that's why it will keep decreasing and decreasing, okay, getting very, very close to 0, but it will never intersect with the 0 x-axis. Okay, what's the logic behind having a decreasing average fixed cost curve? The logic is that as the firm sells more and more output, it will be spreading its overhead cost, or what we also called sunk costs, or its fixed cost, over more and more units, which makes the average fixed cost smaller and smaller. Okay, so it's always better for the firm, of course, to produce more output, because in this case, it is spreading its fixed cost over a bigger amount of output, which is, of course, better for the firm because it will decrease its average fixed cost. Okay, let's look at the next slide, because there we will see the dashed gray curve reflecting the average fixed cost curve, and it will look like a hyperbola, okay, where it will be approaching both the y-axis and the x-axis, okay, getting very close to both of them, but it will never touch them and it will never intersect them. So this is an important graph. It shows us the average cost curves, okay, and how it can be broken down into average fixed cost and average variable cost. It will also show us the marginal cost curve and how it is related to the average cost. Okay, but let's start with the term that we already studied in the previous slide, which is the average fixed cost. As you can see, it is this dashed gray curve. Okay, it is a falling curve because, as we said, the logic is that you are having a fixed number and you are dividing this number by increasing Q. Okay, that's why this number will be decreasing and decreasing. That's why the average fixed cost key is a falling curve or a decreasing curve, and it keeps decreasing. As you can see, it is getting very close to the x-axis, but it's never going to touch it, which means that it will never be 0. What about the other end of this average fixed cost curve? Of course, if we look at Q equal 1, okay, so the average fixed cost in this curve will be 55, because it will be 55 divided by 1 is 55. But you can also think of dividing this fixed cost by smaller amounts of output, even smaller than 1. It could be the case that some industries could produce divisions of a unit, okay, even smaller than 1 unit. In this case, okay, you'll find that the average fixed cost will be bigger than 55, okay, so it will be increasing. Again, getting very close to the y-axis, but never intersecting or touching it. Okay, that's what we mean by hyperbola, average fixed cost curve. Now we're going to move to the second component of average cost, which is average variable cost. So average variable cost is equal to variable cost divided by Q, okay? If we look back to the previous graph, we'll see that the average variable cost curve looks like a U-shaped curve. So until Q equals 3, we'll find that this average variable cost curve is a decreasing curve. Okay, and after Q equals 3, we'll find that this average variable cost will be an increasing curve. So it will first fall, and then it is going to rise. So it looks like a U-shaped. And you can double check this from the table, from the previous table where we had the numbers. So why is that? Why do we have a U-shaped average variable cost curve? This is related to the fact that the total cost curve is an increasing curve, but it is increasing at the beginning by a decreasing slope and then by an increasing slope. Okay, so that's why the average variable cost will be looking like a U-shaped. Okay, and please look at the table to check the numbers. The same for the average cost curve. The average cost curve is also a U-shaped, okay, but it's so it will first be falling and then increasing, okay, but it will be falling until Q equal 4, not Q equal 3. Okay, check the numbers to double check this. There is a very important thing that you need to take a note of on the relationship between the average cost and its components, average fixed cost and average variable cost. So we agreed that average cost is equal to average fixed cost plus average variable cost. This means that the distance between the average cost curve and the average variable cost curve, okay, which represents the average fixed cost, okay, because the distance between the average cost curve and the average variable cost is, of course, the average fixed cost. And we know that the average fixed cost curve is a decreasing curve. So this means that the distance between the average cost curve and the average variable cost curve will be decreasing, okay? So the gap between them will keep decreasing, okay? Because of what? Because of the decreasing average fixed cost curve. This is clear from the previous graph, which I'm going to repeat in the next slide again. Look again at the gap between the average cost curve and the average variable cost curve. Okay, as you can see, this gap starts as a very big gap, and as we move to the right, this gap keeps decreasing. Why? Because the distance between these two curves, or what we call the gap, is actually the average fixed cost. Okay, and since the average fixed cost is decreasing, okay, that's why this gap will keep decreasing and they will keep getting closer to each other, okay? But they will never intersect. Why? Because the average fixed cost will never reach 0. In the previous figure, where we had the different cost curves, we had the average cost curve, the average fixed cost curve, the average variable cost curve, okay? We talked about these different average cost curves. And we also talked about the relationship between the average cost and the average variable cost curve and how that the gap between them keeps decreasing, okay? It still remains one curve that we haven't talked about in this figure, which is the solid pink curve representing the marginal cost. And as you can see, this marginal cost curve, it looks like a semi-U shaped. So it looks like a tick, okay, زي علامة الصح كده. Which means that it will be decreasing curve, okay, it will be falling until a certain range of output and it will then be increasing, okay, because we previously talked about the marginal cost and how it will first be decreasing, okay, reflecting the concavity of the total cost curve, okay, and then it will be an increasing marginal cost curve reflecting the convexity of the total cost curve, okay. So you already know the marginal cost curve and how it looks like. It remains for us to check the relationship between average cost and marginal cost. So there is a very important relationship between the average cost curve and the marginal cost curve. What is this relationship? Actually, there are 3 points, okay, or 3 ranges where we can check this relationship. The first range is when the marginal cost is below the average cost curve, okay, i.e. when the marginal cost is smaller in value than the average cost curve. If you check the figure, you will find that this is the region until Q equal 4. So until Q equal 4, you will find that the marginal cost curve, the value of the marginal cost curve is smaller than the value of the average cost curve. So what will happen in this region if this is the case that the marginal cost falls below the average cost curve? What will happen is that in this region, the marginal cost will be pulling the average cost curve downward, okay? I will explain it on the graph later on, okay, and using the table for you to better understand it. But let me say the intuition behind this. Why, when the marginal cost curve is below the average cost curve, okay, which means that the marginal cost is smaller in value than the average cost, why is it going to pull the average cost down? Okay. The intuition is as follows. If marginal cost is below average cost, this means that the last unit produced will cost less than the average cost of all the previous units produced. This is what we mean by marginal cost is smaller than average cost. This means that the last unit produced, the extra unit, the final unit produced, okay, it costs less than the average cost of all the previous units that have been produced so far. This implies that the new average cost, okay, which is the average cost after including this latest unit produced, okay, so it must be definitely less than, its value must be less than the old average cost, which means that the average cost curve will be falling curve. It will be pulled downward, okay? Pulled downward يعني كأني بشده لتحت, يعني it will be a falling curve. So why is this the case? Let's take another example that might make things better understood for you. So let's think of an example where suppose I entered our classroom and I got scales with me. Okay, جبت معايا ميزان, okay, and I took the weight of each one of us. And then I was able to calculate the average weight of the classroom. Okay, then as usual, we always have people coming late. So suppose that after we took this average weight of the whole classroom, okay, a late student came in and entered the class, but she was a very slim student. This means that the marginal weight in this case will be very small number. Okay, what will this new student that has entered after we already took the average weight of the class, what will she cause to the new average weight? It will definitely pull it down because she's very slim, okay? So she will be pulling the new average downward, okay? Because the average is the total weight divided by the number of students. So the number of students in this case has increased by 1 student, okay? But the total weight, which will be in the numerator, will only increase by a very small amount because she's very slim, okay? Which will result in a very a smaller new average weight. This is the same idea for the marginal cost and the average cost. So when the marginal cost is below the average cost, okay, it will be pulling average cost downward, okay? We will again be looking at the table again and the graph to confirm this idea, okay? But let's move to the second range. What about when marginal cost is above average cost? So when marginal cost is above average cost, which means that the marginal cost in this case will be bigger in value than the average cost, which will happen on our graph after Q equal 4, you will find out that it will be pulling the average cost upward. كأنها بتشدها لفوق. So in this case, the average cost will be an increasing curve. Okay, so let's look at the next table, okay, to clarify this point. And then in the next slide, we're going to look again at the graph to confirm this idea. So let's look at Q equal 1. So when Q equal 1, the average cost in this case was 85. What about increasing Q to be Q equal 2? In this case, the marginal cost of producing this extra unit of output is 25. And this 25 is lower than the previous average cost, which was 85. So what will it cause to the new average cost? So as you can see, the average cost when Q equal 2 is becoming 55. So this means that when marginal cost was lower than average cost, it pulled the new average cost downward. And this will result in a falling average cost curve, okay, in this region. Let's look, however, at Q equal 5 and Q equal 6. So when Q equal 5, the average cost of production was 42. What about increasing output by 1 more unit to be 6? In this case, the marginal cost is 70, which means that here 70 is greater than the 42. 70, which is the marginal cost, is greater than the previous average cost of 42. So what will it be causing to the new average cost? It will be pulling it upward. هتزوده. Okay, so it will be resulting in a new average cost of 46 2/3, okay, which is higher. ده معناه ان the average cost curve will be, in this case, an increasing curve. يعني the average cost curve will be in a certain range, a falling curve, and then in another range, an increasing curve, and this is very much related to its relationship to the marginal cost curve. Okay? Now let's look at this graph to confirm the relationship between the marginal cost and the average cost that we just explained. So let's look at the marginal cost and the average cost until Q equal 4. So until Q equal 4, we'll find that the marginal cost, the value of the marginal cost, is lower than the value of the average cost. بصبعكوا كده مثلا اقفوا على Q equal 3, okay, and go up to the marginal cost, you will find that it is equal to 20 مثلا, okay. What about the average cost? It is equal to 40. This means that in this range, the marginal cost is below the average cost. So what will it be causing to the average cost? It will be pulling it downward. عشان كده until Q equal 4 هتلاقوا ان average cost curve is falling. Okay? طيب, what about when marginal cost exceeds or lies above the average cost? من بعد Q equal 4, you will find that, for example, at Q equal 5, you will find that the value of the marginal cost, امشوا كده بصبعكوا لغاية marginal cost, and then go to the left on the y-axis, you will find that at Q equal 5, marginal cost is equal to 50. طب what about average cost? Average cost From 5, Q equal 5, going up to the average cost, and then to the left, it is 40. This means that in this region, marginal cost is above average cost. So what will it be causing average cost to look like? It will be resulting in an upward sloping or an increasing average cost. So it will be pulling it upward. Okay, عشان كده هيبقى طالع لفوق. So this is the relationship between the marginal cost and the average cost. Okay, in these two ranges, when the marginal cost was below the average cost and when the marginal cost was above the average cost. What about the last relationship between them? It is when they are equal. This is what we will talk about in the next slide. The last region in the relationship between the marginal cost and the average cost is when the marginal cost equals average cost. Because we talked about this region or this range when the marginal cost was below the average cost. And we also talked about this range when the marginal cost was above the average cost. So definitely there is some region where the marginal cost will be exactly equal to the average cost, okay, when it will intersect it. Okay, so when the marginal cost just equals the average cost in this case will not be pulled up or down, it will be constant and it will be at its minimum. This will happen at the bottom of the U-shaped average cost. So we know that the average cost curve looks like a U-shaped. Okay, so at the bottom of the U-shaped, of the average cost, which is the minimum point of the average cost, okay, this will be the point where the marginal cost is equal to the average cost. So the marginal cost will be equal to the average cost, will be equal to the minimum average cost. So this point of intersection when the marginal cost is equal to the average cost, this will happen at the minimum average cost or at the bottom of the U-shaped. Let's now summarize the relationship between the marginal cost and the average cost curves. So when the marginal cost curve lies below the average cost curve, the average cost curve will be falling because it will be pulling it downward. By contrast, if the marginal cost curve lies above the average cost curve in this case will be rising because the marginal cost will be pulling it upward. Okay? And finally, when the marginal cost is just equal to the average cost curve, okay, the average cost curve will be at its minimum point. So the point of intersection between the marginal cost and the average cost always happens at the minimum point of the average cost curve. And that's all for today's lecture.